Best fellow physics students, in this video we are discussing about the symmetrical circuit students. If we want to solve these kind of circuits by using the Kirchhoff's laws, every time we have to go with the loops and as well as a mesh. And also it is a time consuming process. In competitive examinations, you have to do the problems in a short span. Okay, the answer for these circuits is the symmetry. Okay, students, we know about the symmetrical bodies. Simply we can say symmetry means what? Having equal sides, or you can say it is a mirror reflection. It's a mirror reflection. Here, for example, you say it's a mirror, and if you keep an object here, it appears to be same inside the mirror. The same thing is going with this circuit also, students. If you watch it clearly, you will find in this resistor has a resistance of R1 and it's R1, it is R2 and it is R2, and we have two more sets here. To make it easier, we have to locate a axis, students. First we have to locate the axis of symmetry. Here I am locating this axis. This axis is the axis of symmetry. Here the first step to solve the circuit is you have to locate the axis of symmetry. I located. Actually, I have to find out the resistance between the 2 points A and B. Okay, students, this resistor R4 is parallel to the axis of symmetry. And was this resistor R3? It is perpendicular to the axis of symmetry. What does it mean? What potential at C is the same potential at D? Say, is the C as the D. What potential is C? The same potential would be at D. That means what? No current flows between these two. Okay, students. And remember one thing. When we are taking the axis parallel to the points in between, we have to find out the effective resistance. We call it as the parallel axis of symmetry. We have to call it as parallel axis of symmetry. When the axis of symmetry is parallel to the resistance we have to find in between the 2 points, then the resistor which is perpendicular to the parallel axis of symmetry should be removed. Means what? R3 should be removed. Okay, students. Means what? What potential at C is the same potential is D. I am redrawing this circuit again. I am removing this R3. Then what I get? See here is the same resistor R1. Okay, students, and it is the resistor R2 is the point B, and here we have the point A. In between we have a resistor R4, and we got one more resistor here. It is R1. Okay, students, see this R2. It is here. Okay, I'm joining this, and it's the point D as a point A. Okay, students. Let's see. Here, this part is removed. Let's say R1 is equal to R2 is equal to R3 is equal to R4. It is equal to R. Okay, students. Now see, I'm redrawing this circuit again. I'm making it straight. You see, now I get this resistor R1 has a magnitude of R and it is R2. Okay, students, and it's the point A and it is the point B. In between I have a resistor R4 which has the resistance of R and R1 here. Okay, students, it is this one. I said it is R2 again, is R2. It is equal to has a resistance of R again. If you watch these three and just tilt it, what you get? It is the resistor R1 Okay, and it is R2. Okay, it is R, it is a point A as a point B, and it is this resistor R1. You see, this is the R2, it has a resistance of R. Each one has a resistance of R. And now see, these two resistors are in series and these two are in series. Then we can redraw it. When the resistors are series, and you know that resistance is summation of the individual resistances. That is R1 plus R2 plus R plus R, it is equal to 2R. Then it turns to be a resistor of, I'm locating the points A and B here. This is A and this is the resistor. What will form? Has a resistance of 2R and it got a resistance of 2R. Now see students, these three resistors are parallel to each other. Then you know that when the resistors are parallel to each other, the effective resistance or equivalent resistance is the sum of the reciprocals of individual resistances. Okay, let's say it is R1, it is equal to 1 by 2R, followed by the second resistance, that is R plus 1 by 2R, and finally we will get 2 by 1 by 2R plus 1 by 2R, 2 by 2R plus 1 by R, that is 1 by R plus 1 by R, 2 by R. Here 2 to get cancelled. Then effective resistance is equal to R by 2. In this way, you can solve the circuit very easily. Okay, students. I hope you understood how to solve this. You have to locate the axis of symmetry first. Here, when the what's the defective resistance has to be found in between the 2 points and it is along the what's that axis of symmetry, then you have to remove the resistor which is perpendicular to the axis symmetry. You should not remove this, because if you take this resistor R3, if you remove this one, you can say it is R by 2 as R by 2, dividing 2 parts equally. That means what? They are having the same resistance, and these 2 points have the same potential. That's why no current will flow through this. But here, these 2 points are different potentials. A has a particular potential and B got other potential. That this part doesn't have any potential. In that way, we can solve this. What's the circuit very easily. I hope you understood. Let's do one more circuit, students. The circuit goes like this. Let's say it's one resistor, and we have one more. Okay, students, and we got one more here, and it is one. The being connected like this, and they are connected with 2 more resistors like this. Okay, and in between we have a resistor. These are the 2 points. It's a point A and it's a point B. We have to find out the resistance, effective resistance between the point A and B. If it is not here, then you can understand very easily the 2 are in series and these 2 are in series, and finally the effective resistance is series with this 2 resistors. Then the answer will be easy. But this resistor is added, the branch is added here. Okay, then say each and every resistor has a resistance of R. Students. Again, we have to follow the axis of symmetry here, students. Here, I said in earlier you have to draw an axis. Okay, along the points in between, we have to find out the effective resistance. Here we have to find the effective resistance between the point A and B. I'm drawing an axis here. Here's the axis which is passing in this way. Okay, students. It is the axis and it is making 90 degrees, and simply you can say it is the perpendicular axis of symmetry. The perpendicular axis of symmetry. Here in this case, we have to remove the resistor, which is what's that along the axis of symmetry. Means what? This resistance has to be removed. This resistance we have to remove. In previous case, what we did, the same thing we did. We removed the resistance which is perpendicular to the axis of. Okay, students. Here we have to remove this one. Then what we get, the equivalent circuit could be like this. It is R, it is R, and C. It is R, then we have one more R, and it is R, and it is R. These are the points A and B. Very simple. These two are in series, and these two are in series. When they are series, the sum of the effective resistance, say R1, is R plus R. It is 2R. Here also, you say it is R2. That's R plus R. It is equal to 2R. Okay, students. Then we can redraw the circuit. That means what? We are collapsing the circuit. That is, it is 2R followed by one more resistance. It is 2R. And we have one resistor. It is R. And we have one more. It is the point B, R. Say these two. These two are parallel to each other. Then you know that the effective resistance is sum of the reciprocals of individual resistances. If you say it is R1 and it is R2, then it might be R parallel is equal to 1 by 2R plus 1 by 2R. Okay, students. Here, these two are parallel to each other. Then it is equal to 2 by 2R. These 2 to get cancelled, it is 1 by RP. Then RP is equal to R. Okay, student. Then it can be redrawn like this. The two turns into be a single resistor. That is, it is the resistor which has the resistance of R, and the two being connected like this. R. This one is A and B. If you make them straight, they appears to be in series. That means you can redraw this. It is R, and we have one more R, and it is R. These are the points A and B. R plus R plus R. Since they are in series, the effective resistance is sum of the three R plus R plus R. In this way, you can find out the resistance by using the perpendicular symmetry. Okay, students. Okay, students. We have to find out the effective resistance between A and B. That's why I located an axis here. It is the perpendicular axis symmetry. You know that when the axis is perpendicular and the effective resistance is parallel to the axis of the symmetry, then we have to remove the resistors which are perpendicular to the axis of symmetry. That's why I located the points here across these. E and F, that means resistor which is in between EMF should be removed, as well as the resistor between B and C also should be removed. Then we have to redraw the circuit, students. What I am doing, I am removing this one and as well as this. Then it can be redrawn like this. Okay, students, it is the point A, is the point B, and we have a resistor here. We said it is the D. Then these two resistors should be connected to this one. That means it is the resistor, it is BE, in between BE and as well as the ED. One more resistor. Okay, students. In the same way, okay, relocate the points here. It is the same resistor. It is the point C. Then see this resistor. Resistor between the point D and F. This is the resistor between points D and F, and between it is F and C. This is the resistor. Okay, it is the resultant circuit, students. Now what's this? These two I am making or I am collapsing further. Then what I get? The same resistor I am taking here. It is the R. and I am making it straight. Then see, it is the resistor this, and we have one more resistor here. It is R and R. The being connected to D is the D, and it is the A. Okay, see, here it is a resistor, this one in between A and B, it is R. The same, we get the mirror reflection here, it's the R, and we have the two resistors, it is C. Okay, students, the two and these two, they turn to be a single resistor. Then it can be redrawn like this. It becomes a single resistor. Since they are in series, it turns to be 2R. Always it is R only. It is R and it is R. Okay, students, and it might be 2R. Okay, it's the point A and D. Okay, students. Let's see. If you redraw this, everything is happened here. This one and this one are in series. This one and this one is our series. Then we can redraw this one. It is the A, point A, and we have resistor R here. R and 2R in series. That means it turns into a resistor of resistance 3R. Okay, the same will happen here. It is 3R, is the point D. Because then these three are in parallel to each other. And you know that when the resistors are in parallel, I'm redrawing this one. Okay, 1 by Rp is equal to 1 by 3R plus it is 1 by R plus 1 by 3R. It is 2 by 3R plus 1 by R. Well, students, if we take 1 by R as a common, what we get? 2 by 3 plus 1. Or it is 1 by R of 2 plus 3 by 3. It is 5 by 3R. Okay, and the effective resistance or effective is equal to 3R by 5. It is the desired result, students.